Hi, we want to look here at a problem that involves finding the coordinates of a centroid. Remember, the centroid is formed by the intersection of the medians of a triangle. Remember, the medians go from the midpoint of the sides of the triangle to the opposite vertex. So we want to find the coordinates of where that centroid will be. One way we could do this is find the midpoints of each side and construct medians from the midpoints to the vertices. And most likely we would construct it accurately enough where it intersect at the actual centroid, and we could locate the coordinates that way. On a test, on the test that we're going to have, you can't write on the graph. You can maybe do it yourself. So I'm going to show you another way of doing it, and that's we're going to use our theorem that says that from the vertex to the centroid, wherever that is in this case, it's 2/3 the length of the entire median. So we're going to use that to locate our centroid. I've already worked this problem out some, and I found that when I found the midpoints of each side, and I found that when I find the midpoint for side JK, it gives me, from a median that is vertical. From the midpoint to the vertex, it's a vertical line. So I'm going to use that, seeing that it's easy to find lengths with verticals. I won't have to use a distance formula. I'm going to use this median to find the 2/3 point and locate my centroid that way. So for JK, for segment JK, I'm going to find the midpoint of the x-coordinate. That's going to be the sum of the x-coordinates of the endpoints, -2 and 6, divided by 2, and that's equal to 4/2, which is 2. And the midpoint, the y-coordinate of the midpoint is going to be 7 plus 1, sum of the y-coordinates of the endpoints divided by 2. So that's 8 divided by 2, which is 4. Okay, so I'm going to call that point M. And that point is at 2, 4. Notice our scale on our x and y axis, each line is 2. So we're going 2, 4, 6, 2, 4, 6, and so forth. So this is at 2 over and 4 up. Okay? Now I have a median. And I'm going to go ahead and find the length of that median. It's a vertical, so I can just subtract the y-coordinates of these endpoints to get the length of ML. So ML, the distance from M to L, is 4 minus -5, the absolute value of 4 minus -5, which is 9. Okay? So the centroid, remember, we'll call the centroid point P. Okay, so the centroid, remember, is going to be 2/3 from the vertex to the centroid. It's going to be 2/3 the length. So I'm going to find we found the length. Okay, so we're calling the centroid P. So LP, wherever P is here, from L to P, the centroid LP is going to be 2/3. I'll call it LM, the length of the median. Okay, and so we saw LM or ML. Let me just call it. I already called it ML, so let's call it ML. ML is 9, so I'll substitute 9 with ML, and so LP is equal to 2/3 of 9. So LP is equal to 6. Okay. So from -5, I'm going to go up 6, or I'm going to add 6. And I'm at 2 on the x-axis, and I'm going to go up 6, and that's 2/3 the length. So coordinates for P is going to be 2, and then -5 plus 6, which is 1. Okay, so my centroid is 2 over and 1 up. That's the coordinates of my centroid.